this traffic light is what is used for illuminating your road. But the problem with our traffic light system is, or your road light system is, this has to be turned off during the daytime. But then sometimes you can see that because of poor maintenance or lack of attention, this light is on during the daytime, and it is on for 24/7. Interface LDR sensor with Arduino, and hence design street light automation circuit which will turn on the street light during night and turn off the same during daytime automatically. An LDR sensor would change the resistance of this depending upon the light. The resistance would be extremely high during night time. The resistance would be extremely low during daytime. So this change in resistance we convert into change in voltage. So how do we convert this into change in voltage? We construct a potential divider circuit. So we consider this as one end of the resistor. This is my plus 5 volt. The other end of the resistor I connect to a normal ordinary 10K resistor, and I take the output across this resistor R2 and connect to Arduino, analog pin A0 of Arduino. Okay, so you know very well, if the resistance of this LDR changes, the voltage of this also changes. Let me call this as R1 and V1. So total voltage 5 volt is equal to summation of V1 plus V2. V2 is this voltage, V1 is this. So V1 plus V2 is 5. This is constant K. So when V1 is going to change depending upon light, V2 automatically will change. So this is what we are taking to. How V1 will change? V1 would change because V1 is equal to I into R1. This R1 would change. How this R1 would change? This R1 would change depending upon light. Okay. So as V1 changes, V2 also would change. So this change in resistance we are converting into change in voltage. So what is the circuit diagram? Here is my street light which I wanted to control. Okay. So we have power supply line. The other end of the power supply we connect to a resistor and connect this to ground. It's a 10K resistor. The voltage across R2 I connect it to analog pin 0. So this is the sensor part. What is the value that is read by this sensor is monitored for. This is pseudo watt. This is for monitoring purpose. Monitoring means I just wanted to know what is the value. We have an ADC inside. So what is the analog value that is converted into digital data? So what is the value that is received from this sensor? We monitor by using computer. So this is for monitoring purpose. PC is just for monitoring purpose here. It doesn't serve anything. Whenever we put a sensor is normally associated with a control circuit. Okay, so on the right hand side we have the control circuit. On the left hand side we have the sensing circuit. Whenever a microcontroller is interfaced with a sensor, most likely that it is associated with a control circuit. Control circuit means something which takes an action based on the information that is coming from the sensor. This sensor is providing what is the quantum of light falling on this sensor. So once that information is received, what control action this microcontroller does. So that circuit we normally put it on the right. So what is this circuit? This is a simple relay circuit that turns on my street light. So a relay circuit essentially has a coil C1 and C2. This coil we connect to plus 12 volt. This coil we activate and deactivate by controlling a transistor. Emitter of the transistor I connect to ground. Collector I connect to coil. The base terminal I connect it to any control pin. So in this case I am controlling from pin number 13. When pin number 13 is high, this transistor turns on, therefore coil is activated. When pin number 13 is low, this transistor is off, therefore the coil is deactivated. So whether the coil is activated or deactivated is controlled by pin number 13, appropriately by sending a signal high or low. Accordingly, we have 3 terminals on the right hand side, normally open coil or NO, normally closed coil NC, and a common coil. Okay, connection is established under normal cases between normally closed and common. This is what the connection is normally before the coil is activated. The moment the coil is activated, the magnetic field of the coil will pull this relay to normally open and common. So this normally open and common line acts as a switch. This is where we have to connect our load. What is our load? Our load is our street light. This street light has two wires, one the live wire and the neutral wire, or positive and negative depending upon whether you are using AC or DC. So this live wire we connect it to the base. We break this neutral wire. One point we connect it to common. Another point we take from normally open and complete the circuit. So one end of the live wire is going to phase. The neutral wire is broken and it is connected via the switch. When this switch turns on, the circuit is closed. So what is the sequence of operation? When pin number 13 is high, this transistor turns on, this coil gets activated, contact is established between normally open and common line. That completes the circuit, street line turns on. Okay. The reverse would happen when pin number 13 is off. When pin number 13 is low, this transistor goes off, this coil is deactivated, therefore this contact is broken, contact is established between normally closed and common, therefore the street light goes to off state. So I take power supply, so connect one end of the power supply to this, and other end of, I take the ground line and I connect the ground line to this resistor. So that concludes my power supply part. I want to take the voltage across this resistor. So I take this one. This line straight away goes to analog A0. So that is a simple circuit. Voltage of 5 volt. Other end of this goes to resistor. The other end of this resistor goes to ground. And I take the voltage across this resistor R2 and connect to analog. So here on the left hand side we have the sensor. On the right hand side we will put the control circuit. Take a transistor. The central terminal is the base terminal, so which I connect to pin 13. The emitter is something which should I be connected to ground. Collector should go to the coil of the relay. So let me take the relay. So this is the relay. So if you see the schematic diagram of the relay, our conventional relays has 5 terminals. Here this fellow has 6 terminals. If you see, if you understand this diagram, you can understand. So this is my common terminal. Instead of one common terminal, you have 2 common terminals. Both of them are short circuited. You can either take the connection here or here. Both are one of the same. So this relay has 6 terminals instead of 5. The only difference is instead of one common line, you have 2 common points. Both of them are internally short circuited. So either you take connection from here or here, it makes no difference because they are internally short circuited. That is the only difference. So this is the normally closed contact. You can see the diagram here. So the contact established between normally closed contact. So this is the normally closed contact, and this is the normally open contact, and this is coil 1 and this is coil 2. So this is my coil. Okay. So other end of the coil should go to the battery. Let me take a small battery. So positive of the battery, let us connect it to coil 1. Negative has to be connected to the circuit's ground. So let me connect that one to ground. Okay. Now whenever 13th pin turns on, this transistor will activate this coil. Therefore, the contact is established between normally open and the common point. So now you have to connect your load between normally open and the, so the load that I wanted to connect now is the lamp. So you can take a bulb here. So this is the bulb. Okay, so first let us connect the live wire. So this is my live. I'm using the same battery for this lamp also. So the live wire I connected to lamp, and the return wire I'm connecting between common and the, so one point I connected to common. You can either connect here or here. Both of them are short circuit. And where is the normally open line? This is the normally open. That point I take and connect it to the ground point. You can use a separate battery for lamp, but then since I have a battery already, I'm using the same. So that concludes my control part. So this is my control part. This is my sensor part. You need to decide when should you have the control. Okay, so you have to put an if condition here. If light intensity, since light intensity is directly proportional to the quantum of light, so if the light intensity is above, let's say 300 points, this you can do some experimentation and figure out what should be the value. If the light intensity is above 300 points, this anyway you print it. I'm not involved in this. You have to turn the street light on, isn't it? So digital right, street light is connected to 13th pin and it has to be turned high. Else, digital right, 13th pin. Okay, so first of all, you configure 13th pin as an output pin. So pin mode, 13th pin has to be connected as an output. So why I fix this 300? You can fix this value to any value depending upon the intensity of the light. You can do some experimentation and fix this, because during full moon day the light intensity will be lightly higher, and during no moon day it will be completely dark. So you had to take a call and then fix the light intensity value and then control it. I'm fixing this 300 just for your study purpose. You can change it on actual scenario. So if you see the serial monitor, it is currently showing 6. Okay, because the value of the light is too completely dark, and the street light is in off state here. In fact, we are doing the opposite. Means during the completely dark state, the street light should be in on state, right? So only when the light falls, we have to put off the light. So we have to change the condition here. So when the light intensity is less than 300, it has to be completely turned on. So the simulation. So the street light is completely on because it is night, complete night. Why complete night? If you see the serial monitor, it is showing 6, which means the illumination is completely dark. I increase the illumination somewhere beyond 300. That signifies my daylight. So when the daylight comes, automatically my lamp goes off. You can probably during complete. Maybe what I do, I will pull this lamp here. So when the sunlight falls, street light goes off. During complete night, that light turns on. Okay, so you can extend the concept like this. You can interface any sensor. Once you get the sensor and interface the sensor to any analog in pin, and then later on you read that analog pin and then you take a control action. Control action is normally achieved by using a relay. Not necessarily that you needed to be having the relay every time. If it is a high voltage equipment like a street light here, then you naturally need a relay. Otherwise, you can control that by using the conventional port. If it is necessary, you can also optionally put a display like an LCD display. In this case, we haven't interfaced an LCD display. Probably if you require an LCD display, you can add one. You know how to interface an LCD display also. So you can interface the LCD display and complete this project as a full-fledged project if you are interested. Right. I will stop here today.